SLS Selective Laser Sintering. Selective laser sintering is an additive manufacturing technology that uses high-power laser to sinter small particles of polymer powder into solid structure based on a 3D model. SLS 3D printing has been a popular choice for engineers and manufacturers for decades. Low cost per part, high productivity, and established material make technology ideal for a range of applications from rapid prototyping to small batch, bridge, or custom manufacturing. Recent advanced machinery, materials, and software have made SLS printing accessible to a wider range of businesses, enabling more and more companies to use these tools that were previously limited to a few high-tech industries. The powder is dispersed in a thin layer on top of a platform inside the build chamber. The printer preheats the powder to the temperature somewhat below the melting point of the raw material, which makes it easier for laser to raise the temperature of specific regions of the powder bed as it stresses the model to solidify a part. The laser scans a cross-section of a 3D model, heating the powder to just below or right at the melting point of the material. This fuses the particles together mechanically to create one solid part. The unfused powder supports the part during printing and eliminates the need of dedicated support structures. The platform then lowers by one layer into the build chamber, typically between 50 to 200 microns, and the process repeats for each layer until parts are complete. After printing, the build chamber needs to slightly cool down inside the print enclosure and then outside the printer to ensure optimal mechanical properties and avoid warping in parts. The finished part needs to be removed from the build chamber, separated and cleaned of excess powder. The powder can be recycled and printed parts can be further post-processed by media blasting or media tumbling. As the unfused powder supports the part during printing, there is no need for dedicated support structures. This makes SLS ideal for complex geometries including interior features, undercuts, thin walls, and negative features. Parts produced with SLS 3D printing have excellent mechanical characteristics with strength resembling injection molded parts. SLS 3D printing materials. The most common material for selective laser sintering is nylon, a highly capable of engineering thermoplastic for both functional prototyping and end-use production. Nylon is ideal for complex assemblies and durable parts with high environmental stability. SLS 3D printing nylon parts are strong, stiff, sturdy, and durable. The final parts are impact resistant and can endure repeated wear and tear. Nylon is resistant to UV, light, heat, moisture, solvents, temperature, and water. 3D printed nylon parts can be biocompatible and not sensitizing, which means that they are ready to wear and safe to use in many contexts. SLS 3D printing also used for rapid prototyping, mock-ups of product for in-field customer feedback, functional prototyping, and rigorous functional testing of products.